So hi all, welcome to the YouTube channel Mechanical Engineers. And today we are going to start a new series which is pressure vessels. So pressure vessels are very critical asset to any oil and gas or a chemical company. It is important to have a thorough understanding of the pressure vessel and also its integrity checkup. So pressure vessel, it is very important to note here that pressure vessel integrity assessment is also a legal requirement by the statutory bodies. The pressure vessel includes various vessels that contains oil, gas, or any kind of boiler. Boiler, as you know, it is also a pressure vessel. It is very important to note here that if pressure vessels are not maintained as per the guidelines set up by the legal authorities and also by the standards, then it can lead to serious accident and also it can cause to serious injury to people at workplace, and also it can cause a severe reputation damage to the company. So I'm sharing my screen and we will be discussing. Today we will be discussing about the introduction to pressure vessels, the design codes and the software used for the designing of pressure vessels, and the various failure modes in the pressure vessel. The pressure vessel is a closed container that holds liquid, gases or vapors at a pressure which is higher than the surrounding pressure, which is the atmospheric pressure. So, as you can see in this photograph, this is an picture of a pressure vessel which is storing a gas. So, all the pressures of the fluids or gases or the vapors are above the atmospheric pressure. So, we discussed in our last series storage tank. So, what is basically the difference between a storage tank and the pressure vessel? So there are certain guidelines. So a guidelines tell us that if the diameter to thickness ratio is equal to 150, then it is categorized as a pressure vessel. And in case of a storage tank, the diameter to thickness ratio is to 2500. So this is a basically a very kind of mathematical kind of calculation method which defines the definition of a pressure vessel and a typical tank. So there are several design codes that are used for the designing of the pressure vessel, and the most popular one is ASME Section 8. And there are certain divisions to this ASME standard: Division 1, Division 2, Division 3. Then we have other standards: PD, BS, 5500. Then we also have an EN standard, EN 13445. So these are the applicable standard to pressure vessels. So when we are designing any pressure vessel, so these are the things that are taken into consideration. First is the commercial aspect. Then we have the functional requirements. What is the expected requirement from that pressure vessel? Then we have the PFD, which is also called the process flow diagram. Metal selection, data sheets, mechanical designing, fabrication, installation, operations, and once the life cycle is finished, then the decommissioning. So these are some of the softwares which are used for the designing of the pressure vessel. As you can see, there's the Sync Flow, then we have the Compress, then CII. So these are the some of the. Then we also have the most popular one is the ANSYS. ANSYS is the most popular one. So these are some of the software which are used for the designing of the pressure vessel. So why it is important to properly and very design the pressure vessel is because they are subject to certain kind of failures. So these are the certain failures which can occur in a pressure vessel. First is the plastic collapse, buckling, fracture, leakages, and so we have to taken into consideration all these failure modes while we are designing any kind of pressure vessel. So these are the things. Then we have the material damages mechanism. Material damage due to fatigue, due to creep, due to corrosion, erosion, or environmentally assisted crack. So So there are certain, we could see there are certain, I've written a brief description about these kind of failure modes. The failure mode applied to all the positive pressures. Then the fatigue depend upon the number of load cycles. Then creep depend upon the time or temperature, and fracture and applies to all the positive pressure and the lower pressure vessels. So we shall be covering more in details about all these pressure vessels. So thank you for watching the video. We shall be covering more in detail in my upcoming video. Thank you.